Welcome to Study Loop.
Let's evaluate the definite integral from 1 to 2. We see the integrand, we have polynomial divided by polynomial. Since the numerator and the degree have the same denominator, let's go ahead and do polynomial division. Now, x cubed divided by x cubed is just 1. So we have x cubed plus x squared, subtract, and we have 4x squared minus x squared, 3x squared, plus x, and then minus 1. And this is our remainder because x cubed over here does not go into x squared. So this means we can write the fraction as our quotient, which was 1. Then we had a remainder of 3x squared plus x minus 1. And then we have the original denominator on the bottom. So now we're ready to do partial fraction decomposition. And the first thing is to go to that denominator and then factor out x squared. And then we have x squared plus 1. Oops. X plus 1 left over. This is what the book would call case 2 because we have a repeated factor here. We have x is appearing twice. In other words, I'm just saying x squared is x times x. So this is repeated. So using what the book calls case 2 here, we can rewrite this fraction. So first let me write this out. Then I have x squared, x plus 1. So case 2, as the author calls it, we'll have a over x, b over x squared, and then another constant over x plus 1. So the next step here, which we'll do on the next page, is to go ahead and multiply both sides by the denominator on the left. All right, on to the next page. So after multiplying, denominator on the left gets canceled out. Then we have a, x times x plus 1, b, x plus 1, and then cx squared. Now let's go ahead and just take this right-hand side, and let's rewrite the left. And on the right-hand side, let's see, we can rewrite this as x squared. Running out of room up there. That's just x squared plus x. So let's factor out x squared. We have a, and then we'll also have c. Then let's factor out an x term. We'll have a again, and then we'll have a b as well. And then for the constant term, we'll just have a b. So looking at the coefficients on the left and the right, in front of the x squared, we see a 3, and on the right, a plus c. That gives us one equation. In front of the x on the left, we just see a 1. On the right, a plus b. That gives you another equation. And then finally, on the left, we see negative 1. On the right, we see a b for the constant term. So that gives us b equals negative 1, and that's already one of our values. Let's plug this into the previous equation in green. So plug in b equals minus 1. You have a plus negative 1 equals 1, or just a equals 2. And then plug this value of a into the equation in red. You have 2 plus c equals 3. So c equals 1. So now we have the integral let's actually go to the next page. So we'll just plug in our values for a, b, and c into the partial fraction decomposition on the previous page, and we'll integrate. So we have 1 plus, and then actually here, let me take a step back, just in case we had forgotten what's on the first page. So we were at this step right here. After we did long division, this was the thing that we were integrating. And then we did the partial fraction decomposition, and we just wrote this as, now we have 2 over x, negative 1 over x squared, because b was minus 1, and then c was 1. So 1 over x plus 1. And now the next step is just to integrate. So just go ahead and integrate. We're integrating from 1 to 2. 1 to 2. Now we can go ahead and integrate these. So the first term just becomes an x. 2 natural log of x. Absolute value in there too. And then using the power rule, we'll have a 1 over x. And then finally, this looks very similar to the second integral. So if that plus 1 is bothering you, just go ahead and do a u substitution. And after doing so, you should get natural log, absolute value, x plus 1. And we have our endpoints 1 to 2. Now we just plug these endpoints in. Plug in the 2 first. That's when we plug in 2. And then when I plug in 1, 1 plus 2 ln 1, which will be 0, plus 1 over 1, plus ln of 2. Now we just cancel off as much as we can. So we see that this positive 2 here will cancel with this negative 2 on the bottom. So we have a 1/2 left over. And then we have a 2 natural log 2 minus natural log 2. So that's just natural log of 2. And then we have a plus ln 3. So we can write that as our answer, or we can use a property of the logs to write this as ln of 2 times 3. So that's ln of 6. Either one of these is fine. And that's our final answer.